Reference Lab for the SANCUS project, including the following main 5G core network elements necessary for common 5G applications. The grey-out elements will not be a part of the NOKIA SANCUS Reference Lab. The 5G NFs integrated and validated faction-wise in the SANCUS cluster are AMF, UPF and SMF, NRF and NSSF. Container infrastructure of the SANCUS lab. The selected container infrastructure for the 5G core is the CentOS-based Kubernetes platform developed by NOKIA called NCS. NCS is deployed in CNB mode, meaning that the OS hosting Kubernetes and containers is deployed directly to the hardware. The system consists of a control manager that hosts the Kubernetes control plane aspects using the API endpoints and a number of worker nodes that execute application workloads for the cluster users. "5G attacks generation and detection. The attack is generated on 5G replay and it is detected by the seed engine through installed agents on all worker nodes that capture interesting AMF traffic. Each attack is executed from a terminal and it is detected and displayed on MMT operator UI. 5G nominal traffic. As derived from the net load generator that consists of all independent simulators, KPI printout shows the continuity of 5G traffic. As reflected on the MMT operator UI, interesting traffic is captured by the seed agents on VLAN 921 and then through the Kafka bus is presented on the UI. Use Case 1, Attack Scenario 1, Malformed Packet Flooding on NGAP Protocol. Malformed packet floods are DDoS attacks, normally come at a very high rate and aim at consuming of computing power and saturating bandwidth, while also crash devices in rare cases. 5G replay is configured to detect NGAP protocol messages sent by the UE during the authentication exchange and replay them to the AMF, changing the HTTP protocol identifier from 60 to 0 in such a way that we could evaluate the robustness of the core services against malformed NGAP packets. Case 1A. Modify HTTP protocol identifier. Attack is executed on the 5G replay terminal. Attack is detected and identified on the MMT operator UI. More than 4,800 packets captured by the seed agent. Any attack is classified by its property ID, the type, the verdict, and the description. Also, source and destination IPs can be revealed. By looking at the nominal traffic, the new classified packets disrupted the data stream since HTTP abort messages sent by the AMF as part of its internal mitigation mechanism. Case 1B. Modify field inside the NGAP layer. Attack is executed on the 5G replay terminal. Attack is detected and identified on the MMT operator UI. 7 packets captured and marked as not respected, since the modified field inside the NGAP payload resulted to malformed NGAP message. Again, the source and destination IPs are visible. In our case will be the same, since 5G replay and AMF IPs remain unchanged. Attack Scenario 2: NAS 5G SMC Replay Attack. A malicious actor with access to the NAS traffic at the N1 interface could intercept an NAS SMC clear message sent from the AMF to the UE, copy its NAS sequence number, and use it to build a NAS SMC message that it is replayed to the AMF, or directly intercept an NAS SMC message and replay it to the AMF. Attack is executed on the 5G replay terminal. Attack is detected and identified on the MMT operator UI. NAS security mode complete messages with the same NAS SQN. This is marked as a possible replay attack. The source and destination IPs will be necessary for further mitigation actions.